Statistical approach.
Statistical approaches to determine sample size are based on inferential statistics, mainly the confidence interval and hypothesis testing.
The former uses parameter estimates to compute the sample size, while the latter makes use of the effect size, alpha, beta, and the population standard deviation in the calculation.
The sample size determination for confidence intervals presented in this manual was adapted from Malhotra, while the effect size approach was adapted from Brewer.
Sample size considerations using the confidence interval approach.
This approach is based on the construction of confidence intervals around the sample means or proportions using standard error formula.
Sample size determination using mean.
The following steps are used to determine the sample size.
Specify the level of precision, D. This is the maximum permissible difference that the researcher would like to set.
Specify the level of confidence, also said by the researcher.
Determine the z-value associated with the level of confidence set in B, using the z-distribution table.
Sample size determination using mean.
Determine the standard deviation of the population, S. This is determined based either on some secondary sources, empirically derived from pilot tests, or defined judgmentally by the researcher.
Calculate the sample size using the formula for the standard arbor of the mean.
Sample size determination using proportion.
If the statistics of interest is proportion, the following steps should be used to determine the sample size.
Specify the level of precision, D.
Specify the level of confidence.
Determine the z-value associated with the level of confidence set in B, using the z-distribution table. Estimate the population proportion. This can be done based on information from previous studies, derived empirically from pilot tests, or judgmentally defined by the researcher.
Calculate the sample size using the formula for the standard arbor of the proportion.
Sample size considerations using effect size method.
There are three major factors need to be considered in determining the minimum sample size using this method, namely the alpha value, power and the effect size.
The alpha, power and effect size are set by the researcher prior to data collection.
Alpha is the probability of rejecting the null when the null is indeed true. Because the focus of hypothesis testing is to minimize the errors in making a decision, an adequately small value of alpha is essential for the results to be meaningful. Power is the probability of correctly rejecting the null. Since power refers to correct rejection, for the rejection to be meaningful, the power should be set substantially high.
Effect size, ES, is the degree of association between the variables under investigation.
If the study is concerned with differences between two populations, then the effect size refers to the magnitude of difference that make it meaningful.
A small effect size will allow the researcher to detect even a small effect of the phenomenon.
For example, if it is hypothesized that there is a true difference between male and female employees in terms of their job satisfaction levels, a small difference in the mean scores of these two populations, if the null is rejected, is good enough to provide evidence of practical importance if the effect size is set to be small.
A small effect size is able to detect even small true differences if there is a difference between the null and the alternate hypothesis.
Using this method, mainly in hypothesis testing, the minimum sample size is defined as a function of alpha, power and the effect size.
For one sample hypothesis testing, the minimum sample size is defined as.
For hypothesis testing involving two independent samples, the minimum sample size for each population is defined as 1. The list of elements from which the sample is actually drawn is called the 2. A good sample is one in which there is no bias from the sampling process. This is defined as 3. Area sampling is a form of.
For each of the following research questions, it has not been possible to obtain a sampling frame.
Suggest the most appropriate non-probability sampling technique to obtain the necessary data, giving reasons for your choice. What can social services provide to homeless people? Which television advertisements are most remembered by the public watching last weekend?
How are manufacturing companies planning to respond to the introduction of highway tolls?
Would users of a squash club be prepared to pay a 10% increase in subscription fees to help fund 2 new extra courts? Answer needed by tomorrow morning.
Summary.
The logic of sampling is that there are similarities among the elements in a population that can adequately represent the characteristics of the total population.
Some of the elements may underestimate the true value of the population, but others may overestimate the value. The combination of these estimates gives the statistics, which give a true value estimated population.
A good sample should be accurate. There is little or no bias or systematic variance.
A good sample must be precise. The sampling error is within acceptable limits for the purpose of the study.
The choice of the sampling design depends on the objectives and the research questions of the study.
The size of the sample depends on the accuracy of the results required, the confidence level of the study and the resources available to collect and analyze the data.
The probability sample design is the ideal design, since it allows the determination of the level of error likely to be produced. It is often time-consuming and expensive.
Stratified and systematic samplings are modifications to simple random sampling. A sampling frame is needed to apply probability sampling.
If the sampling frame is not possible, a non-probability design can be applied.
The non-probability techniques are a compromise between accuracy and cost of collecting data. Non-probability sampling has many advantages, especially ease of use and reducing cost of data collection. In some instances, probability sampling is the only feasible method of data collection.
Key terms.